In this lesson, we are going to talk about resonance in AC circuits. Okay, so consider a standard RLC circuit. Okay, you have a R, you have a L, and let's just say you have a C. Okay, we are assuming there is some AC voltage that it is connected to. Okay, now what is the impedance due to resistance? It is simply R, right? What is impedance due to this inductor? It is J into XL, right? And what is impedance due to this capacitor? It is minus J into XC. Okay, what's your XL over here? Your XL is omega L, right? And what's your XC over here? Your XC is 1 upon omega C. Okay, now omega is given by what? Omega is 2 pi into frequency. Okay, so your XL also therefore is 2 pi F into L, and your XC is also 1 upon 2 pi F into C. Okay, so your reactance is a function of your frequency. Okay, your inductive reactance is a function of frequency, and your capacitive reactance is also a function of frequency. Okay, for your inductive reactance, if your frequency goes up, your XL also goes up. Okay, it is directly related. For your capacitive reactance, if your frequency goes up, your capacitive reactance goes down. Okay, it is inversely proportional to frequency. Okay, so if I'm going to draw a plot of my frequency on x-axis, okay, and my, let's say, inductive reactance on y-axis, then what would be the graph? Look, you have XL directly proportional to F. Okay, so your XL or your inductive reactance is going to directly increase as your F increases. Okay, so this is your F, okay, and this is your XL, okay, or your inductive reactance. Your inductive reactance is going to keep on increasing as frequency is increasing. Okay, if you are going to draw a plot of your capacitive reactance against your frequency, you are going to realize that your frequency decreases as, or rather your capacitive reactance decreases as frequency is increased. Okay, so if you're starting from 0, your plot is basically going to be something like this. Okay, why do we have this in negative direction? Because my capacitive reactance is minus JXC. Okay, my capacitive reactance is negative and my inductive reactance is positive. Therefore, I have shown it in positive direction, and this guy I have shown it in negative direction. Okay, now can you find out the net reactance of the circuit? Your net reactance is simply going to be your inductive reactance minus your capacitive reactance. Okay, let's say you want to draw a plot of your net reactance versus frequency. Okay, so basically you are just looking at subtracting your XL minus XC. Okay, if you want to find out what is net reactance at this point, all you have to do is find out XL, okay, which is this much. Okay, find out XC, which is this much. Okay, so you subtract XL minus XC, you are going to get your net reactance X, which is going to be somewhere over here. Okay, so if you were to draw a graph between your net reactance X and your frequency, just realize how is your XC behaving. At very low frequencies, your XC is very high. Okay, if you're going to extend it, it's like this. At very low frequencies, your XC is very